Alright, hey, I am back, and we're going to be doing some more of the Python tutorials today, because we made it a pretty good way through it last time. So we're going to pick up where we left off, and yeah, I guess there's no reason to not jump right into it, so let's get started. Alright, so last time we left off, it was with the Pig Latin. So we're going to be going through and making something that converts a user inputted string into Pig Latin. So please print the phrase Pig Latin. Helps if you don't hit caps. Well done. I've just met my goal, my weekly target of work on this every Wednesday when I stream. Input. Next we need to ask the user for input. In the above example, raw input accepts a string, prints it, and then waits for the user to type something, press enter, or return. In the interpreter, Python will ask, what's your name? Once you type your name and hit enter, it will be stored in name. So it takes the variable name and sets it to whatever you enter into there, and then it prints that variable that you stored your name in. So on line 4, use raw input, enter a word to ask the user to enter a word. Save the results in a variable called original. So we'll go original is equal to raw input, and we need to do enter a word and a space. And so enter a word, we'll do Python. And so now we have that word Python stored in the variable of original. Check yourself. Next we need to ensure that the user actually typed something. Empty string is equal to an empty string. If length of empty string is greater than 0, run the code, else that string must have been empty. So write an if statement that checks the length of original. So we're going to go if length of original is greater than 0, and then we will print original. And then we will go else print empty. And we will run that, and I'll print Python again, or if we rerun it, we can enter nothing and it'll print out empty. When you're confident your code works, continue to the next exercise. Now we know we have a non-empty string. Let's be even more thorough and check that our string only contains letters. In the first line, we create a string with letters and number. Second line then runs the method isAlpha, which returns false since the string contains non-letter character. You can use isAlpha to check this, or that a string doesn't contain any non-letter characters. For example, and then it gives you instruction. Doesn't give you an example. Use and. So isWord and we'll go original dot is alpha. Although we need to actually put that on the if statement, like that, then it'll print original, or else it will print empty. So we'll go Python, it runs that way. We'll run it again. Empty prints empty, and here we'll do. We'll wait for it to load. Alright, so we'll just sit here and patiently wait for... Okay. Interesting. What is actually going on? Let's see. Welcome to the Pig Latin Translator. And huh. I think we broke it. So what it's supposed to do is it will work if the original word, or the variable original, contains numeric values. It'll print empty because it doesn't satisfy both halves of this if statement. That is so weird. Okay. When you finish one part of your program, it's important to test it multiple times using a variety of inputs, which is what I did when I broke their code editor. Take some time to test your current code, try some inputs that should pass and some that should fail. Enter some strings that contain non-alphabetical characters and an empty string. Let's run the code. Okay, so I think I'm going to have to actually just refresh the page. There we go. Now it's working. So I'll enter Python. We'll refresh the site. We'll run the code. I'll make sure I'm over here in the terminal. There we go. Python works. We'll run the code. Click over here. We'll enter nothing. We get empty. Cool. We'll run it. We'll do... We get empty because it contains integer. Run it again. Empty, because that's not a word. Or not letters. So, I think we've gone through, we've tested a word, we've tested an empty string, we've tested numbers, we've tested non-alpha characters. And I broke it again. For whatever reason. It's not registering that I've clicked over in the workspace. Actually, let's do... Alright, so it is working like it should. So we can move on to the next one. So now we can get ready to start translating to Pig Latin. Let's review the rules of translation. It's basically taking the first letter, moving it to the end, and adding an AY. So igpe atenlay, essentially. So let's create a variable named pig and set it equal to a. Now we can move on to the next. Let's make the letters in our word lowercase. So we'll use the dot lower function. So it'll be, so we'll print original dot lower to have it all lowercase. So we'll create a variable called word. It will be equal to dot lower. Then we'll create one called first, which is equal to okay, not original, word, because we just created it in lowercase. So first is going to be the letter at the or index 0 of whatever is typed in, which Python is a 0 index, so that index 0 is going to be the first letter. So now we can run this. We can enter Python. We can refresh the browser because we'll run it, make sure I'm clicked over there, and we'll type Python. Are you kidding me? What the hell is going on with Codecademy this week? We'll run my code. We'll make sure I'm clicked over here. Huh. Oh. I need to actually print the word. So clearly I'm clicked over there. Okay, now it prints everything lowercase like it should. Alright, so now here we're just going to concatenate all of the things. So we're going to do new word. That's going to be equal to word plus first plus pig. So this isn't going to be right. Actually, let's so it's not right because we haven't removed the first letter of the new word. So we're going to use a built-in function to pop that first one. Okay. So we're going to create So does it really want us to do it this way? I don't feel like that's right. I feel like there's an easier way to actually accomplish the same thing. That just seems convoluted to me to have to go around that way. I love that they're like, you're going to want to take out any print statements you are using to debug. Hooray! So we've created Pig Latin, and it's very easy. So they want me to go back and redo the Mad Libs now that we know how to enter user input. So we have this where we can do so essentially it'd be like this. Then we would do story with input 1, input 2, input 3, so on and so forth. Then I can save this and run it. I'm just stuck on house. So if I remember right, that should work like that. I don't know why that actually didn't work. Not certain why that didn't work. I could run back through all of this. Did we do that in conditionals and control flow? No. Did that here. So this is so do I need to do it this way? Yep, okay. So I forgot the percent sign. But that's essentially how you do a Mad Libs. You write your story, then for everything that you want to have inserted into it or have your user enter, you would use it as an input, give them the prompt, and send it to lowercase. You just save it to the variable. And then you just make sure you have enough that match up. And then you print your story with your inputs listed in it. And then you call your function. The Mad Lib was that simple. So now we can go back to the syllabus and go back to here. Okay, what good are functions? You might have considered the situation where you would like to reuse a piece of code with just a few different values. Instead of rewriting the whole code, you can define a function, which can then be used repeatedly. check out the code in the editor. They've defined two functions, tax and tip. So in the tax function, you're passed a variable, or you're passed a value of bill. So you take that value of bill, multiply it by 1.08, or multiply it by itself times 1.08. Then you print with tax and give it the total of the bill, and then you return that. So essentially what you're doing is you're saying inside of this function, the number here will from here on out be referred to as bill, or the variable bill. So when you call it down here, you can go meal with tax equals, you call the function tax, and where that variable bill would be, you pass in meal cost, so you pass in 100. So now this up here, it's going to be 100 multiplied by equals 1.08, so that variable, or that meal cost, is going to be that 100 times 1.08. And then it's going to print that total, and it's going to return it. So now meal cost with tax is equal to what the result of this function was. And so now we pass that over here into the tip. So now the meal with tax variable we defined in tax is passed into tip and calculated, and then it's returned back out, and so we can print that. So they say, see how much of the code you understand at first glance. We'll explain it all soon. When you're ready, click run to continue. Which I suppose I could have just waited, and their definition or their explanation is going to be probably a little bit more concise than mine. So we'll just run through it. So with tax, it's 108. With tip, it's 124, because they took the bill here, which is the meal cost equals 100, and ran it through the calculation there to return it. So 100 times 1.08 is 108. And then they passed that 108 into this function here to multiply it by 1.15 and return that to get the 124.2, and it gets printed out right there. So the header, which includes the define keyword, the name of the function, and any parameters the function requires. Here's an example. Define hello world, and there are no parameters. It just will do whatever is defined behind it, and it's not changing. And so you can have it just print hello world, just like that. So you have define hello world, and all it does, and all it will ever do, is print hello world. But you could take define hello world and have like phrase right here, and just be phrase equals to, and put like a user input, and then have it print the phrase, and it would be different. Actually, you wouldn't do a user input. Well, you could, but yeah. So go ahead and create a function that prints the string eggs. So we'll do define spam that will just print eggs with an exclamation mark, and that's it. Really? It's always the stupid stuff. Fine. There. You happy? I did it. Then call and response. We've set up a function square. Call it on the number 10 by putting 10 between the parentheses of square on line 10. On line 10, we'll just go square the number 10. And so now it's going to go through. Let's go 10 to the power of 2. And it's going to take the two variables here. So it's going to print this number that you pass down here squared is, and then it's going to print the result of the calculation here. Here, n is a parameter of square. Parameter is a variable that is an input to a function. It says later, when square is used, you'll be able to input any value you want. But for now, we'll call that future value n. And functions can have any number of parameters. The big code base that I have to deal with at work has some functions that have 10 to 15 different parameters in them, and it's ridiculous where they get them all from. So check the function in the editor. Power, it should have two arguments, a base and an exponent, and raise the first to the power of the second. It's currently broken, however, because parameters are missing. Replace these with base and exponent. Then replace the dashes with the parameters base and exponent, and call the power function with the base of 37 and an exponent of 4. We're going to go 37 and 4. And so it gives us 37 to the power of 4 is 1,874,161. Because it's taking these two, assigning it to base exponent, doing the calculation here, and then printing it out. The functions calling function. We've seen functions that can print text or do simple arithmetic, but functions can be much more powerful than that. For example, a function can call another function. So define one good turn with a parameter of n. It's going to return n plus 1. Then the function deserves another, takes the parameter of n again, and it returns n plus 2. Change the body of deserves another so that it always adds 2 to the output of one good turn. So we're going to return just like that. And so now this function calls this one. So it takes n plus 1 plus 2, and that's what it returns. And so now we're just going to make a couple more. define that section or second function. Define by 3 Okay, define a function called cube that takes an argument called number. Don't forget the parentheses and the colon. Make that function return the cube of that number, i.e. the number multiplied by itself and multiplied by itself once again. Define a second function called by 3, and that takes an argument called number. If that number, so if number modulo 3 let's see, should call cube return cube cheese. I believe that's what they're asking for. I always want to do that. Okay, so I missed actually comparing the number to something. That was the only mistake I made. Okay. Remember, import. Before we try and fancy importing, let's see what Python already knows about square root. So we'll ask it to print on line 3, because I can follow directions. $25. I needed to count up there. So and now we've imported the math module, and we've told it to use from the math module, use the square root function. If you don't want to do that, you can do like that. And that'll do the same thing. So instead of having to define that you want square root from the math module, whenever you call square root, you have just told it from that module, import this very specific thing. Why? I always explain everything one step ahead of Codecademy. However, if we only really need the square root function, it can be frustrating to have to keep typing math.squareroot. It's possible to import only certain variables or functions from a given module. Pulling in just a single function from a module is called a function import, and it's done with the from keyword. Now you can just type square root to get the square root of a number. No more math.squareroot. So, remember that thing I literally just did, where I went from math, import square root? That's what it wants me to do. Then in the next one, oh, you can also use a wildcard to pull everything. So you can go from math, import, and that apostrophe means every. So this is going to import every function from that math module. Universal imports may look great on the surface, but they're not a good idea for one very important reason. They fill your program with a ton of variable and function names without the safety of those names still being associated with the modules they came from. If you have a function of your very own named square root and you import math, your function is saved. There is your square root and there is the math.squareroot. You can do from math, or if you do from math import everything, however, you have a problem. Two different functions with the exact same name. Even if your own definitions don't directly conflict with names from imported modules, if you import all from several modules at once, you won't be able to figure out which variable or function came from where. For these reasons, it's best to stick with either import module and type module.name, or just import specific variables and functions from various modules as needed. And that obviously makes sense. The code in the editor will show you everything available in the math module. Click run to check it out. You'll see square root along with some other useful things like pi, factorial, and trigonometry. So you've got your all of the different functions that come along with the math module. Now that you understand what functions are and how to import modules, let's look at some of the functions that are built into Python. No module is required. You already know about some of the built-in functions we've used with strings, such as .upper, .lower, string, and length. These are great for doing work with strings, but what about something a little more analytic? What do you think the code in the editor will do? Click run when you think you have an idea. So the define biggest number, or the biggest number function, is going to print the largest number in the array, so it is going to print 10. Smallest number is going to return -10 after printing it, and distance from 0 is going to print 10. So it's going to be 10, -10, 10. Those are all some pretty simple functions. The max function takes any number of arguments and returns the largest one. So maximum equals max with and it returns the largest one of those numbers. Min returns the smallest of a given series of arguments. Go ahead, set the minimum equal to min of any set of integers or floats you would like. And it's going to print that -73. The absolute function returns the absolute value of the number it takes as an argument. So we're going to do the abs of -42, and that is going to be 42. I'm sorry, I'm just super yawny today. It's pretty bad. So last night I ended up staying up until like 2 a.m., 2:30, something like that, and I have to wake up at 6:30 at the absolute latest for work. So it was just a night of not enough sleep, and I normally require like 18 hours to function. So you're gonna have to bear with me. I might be a little sluggish, a little jumbled, but we'll get through it. Finally, the type function returns the type of data it receives an argument. If you ask Python to do the following: print type 42, print type 4.2, print type spam, it's going to tell you integer, float, and string. Have Python print out the type of an integer, a float, and a string in the editor. You can pick any values on which to call type, so long as they produce each one. Type, we'll do Python, we'll do type 100, and then we'll do type, just for funsies, -10. So because we're in Python 2, I can just do it this way to not have to deal with the parentheses that you would for Python 3 syntax. You need to make your float actually a float and not a string to make this work. Like I said, gonna be jumbled. Okay, let's review functions. Let's try review functions. Really? Let's try review functions. Again, the example code above is just there for your reference. First, define a function shutdown that takes one argument, s. Don't forget the parentheses or the colon. I'm gonna go def shut down. It takes s. Then if s is equal to yes, we'll do it this way. S dot lower going to return shutting down. Elif s, we'll do dot lower is equal to no return shutdown aborted. Else return sorry. Okay, so they're like, hey, do this, but they don't give you anything. So we'll do user input, right? Or is it raw input? You need to print the name of the function correctly. I didn't print it. It's not going to do anything. Yep. I just realized that as you were typing it, Jeff. Yeah, we'll do it in each one of the... Oh. Where do I want to print it? Yeah. Well, I could just do it that way. Boom. Nailed it. Yeah, that's understandable. I've seen a bunch, like I work with a giant C# code base that has print statements whacked all over it for debugging with no documentation, and it's atrocious. Having a function just nice, clean, precise, and easy to read definitely makes sense. So you import the math module in whatever way you prefer, call it square root function on the number, and print that value into the console. We'll do it the lazy way. 3689. Done and done. But we could also do it the way where we do import math and then we print math.square root with a number in it. Both ways work. It all depends on how many different functions or modules you're going to be importing. Let's see, first define a function called distance from 0 with one argument. So define from 0. It's going to take n for number. If the type of the argument is either int or float, it should return the absolute value of the function input. So we'll go if n I forgot, is there actually like an n.type? Int or actually those to be like so. Then we will else boom. We'll do that. Isn't that the way it's run? It should be n.type. Oh. It does it that way. I always do that. I always grab them wrong. There we go. Fixed it. Trial and error over the little stuff that I never use. So we're going to go back through all of the functions and everything in Python. So we're going to define answer as we start to go on to Hitchhiker's Guide to the Galaxy now. And yeah, that's all that we need to do. Is just define answer and have it return the value of 42. Let's use functions to calculate your trip's costs. Define a function called hotel cost. Need to define it first. It takes one variable called nights. Return $140 times nights. And we will run that. Then we're gonna need to take a plane ride to get to your location. Ugh. I'm going to go step out real quick. I will be right back. I'm going to grab a caffeinated beverage. So give me a few minutes and I will be right back. Okay, I am back. I have a caffeinated beverage, and hopefully that will wake me up a little bit. Okay, so I need to define a function called plane ride cost. It takes a string of city as the input. So I'm going to go if city is equal to Charlotte. Return 183. Elif. We'll just grab all of this again. Equals Tampa. Turn 220. City is Pittsburgh. Return 222. If the city is Angeles. Turn 475. And that's what it was looking for, so we have that done. We can move on to the next one. So now we're going to create a function called define rental car cost, or called rental car cost. With an argument of days. And so now we're going to go So we're going to look at the example here. Where we do, we'll do cost is equal to 40 times days. Right? Then we can go if days is greater than 7, cost let's see, we're gonna go cost is minus equals 50 return cost elif days, actually it's going to be greater than equal to. We're going to go greater than to 3 cost minus equals 20 return cost. That should do it. What? Rental car cost. Define rental car cost. Takes days. So for every day you rent the car, or every day you rent, the car costs $40. The cost is equal to 40 multiplied by your days. If you rent the car for 7 or more days, you get 50 off your total. If days is greater than or equal to 7, cost equals cost minus 50. Then you turn that value. If days greater than or equal to 3, cost equals cost minus 20, return cost. Just like the example above, this check becomes simpler if you make the 7-day check an if statement and the 3-day check an elif statement. Done. Run. So why? Interesting. I was apparently tabbed. Because I'm an idiot. Else, return cost. There we go. Fixed it. It only took me a little bit. So pull it all together. Below your existing code, write a function called trip cost. Take city and days. City, days. Okay, so notice that we changed the argument of hotel costs from nights to days minus 1. Since we want trip costs only depend on 2 parameters, we have to convert the variable nights into days. If you're going to be staying somewhere, the number of nights you stay there is 1 less than the number of days you were there. So this is going to be days. And it's going to be there. So it's going to be hotel cost, it's going to be days. Which is funny, they say, notice we did the thing. Oh, I don't need to change it up here. I can leave that just fine. So, we're going to do total equal to going to equal rental car cost days plus hotel cost days minus 1 plus plane ride costs just like that. Modify your trip cost function. Add a third argument. Spending money. Modify what the trip cost function does. Plus spending money. So you're going to print trip cost Los Angeles for 5 days with an extra $600. That's going to be $1,815 is the total for that trip. So number guess. So we'll do this over here. We'll just save that for later. I have big lat here, but we did that in the actual exercise, so we really don't need that. That can go away. I thought it was a pro project, not a part of something later on or earlier. And so now we get to start with lists. They're like using the indexes, but different. Lists are a data type you can use to store a collection of different pieces of information as a sequence under a single variable name. Data types you've already learned about, including strings, numbers, and booleans. You can assign items to a list with an expression of the form. List names equals square brackets item 1, comma, item 2. And you'll notice that that example over here, the zoo animals, looks familiar to when we were getting the first letter of a word for the piglet. It's because the first animal at the zoo is the variable zoo animals at index 0, which is the pangolin. So with the items in between brackets, you can assign items to a list with an expression of the form list name equals items brackets with the items in between brackets. The list can also be empty by just not adding anything in between the brackets. Lists are very similar to strings, but there are a few key differences. List zoo animals. Excuse me, sorry. The list zoo animals has 3 items. Check them out on line 1. Go ahead and add a fourth. Just enter the name of your favorite animal as a string on line 1 after the final comma, but before the closing bracket. So I don't know what my favorite animal at the zoo is. I really don't. We'll go with a polar bear. And we'll run the code. Cool. And so now, once again, because Python is 0 indexed, we have 4 items that are going to be 0, 1, 2, and 3. And actually, I think I am starting to crash so hard. It has been just a long day at work. I think I'm actually going to cut this stream short. I'll go till we finish this module, the next 12 little micro lesson things. And I think after that, I'm going to call it quits for the night so I can get to bed a little bit early and be much more well rested for tomorrow when we get going on Meramos again. So we'll power through this, and then I'm going to be calling it quits for the night. So access by index. This is the follow-up on the earlier one where I said it was 0 indexed and you had to use 0, 1, 2, 3, 4, whatever to access the items inside when we printed them out. So you can access an individual item on the list by its index. An index is like an address that identifies the item's place in the list. The index appears directly after the list name in between brackets like this. So list name, square brackets, and then that'll be like typically an integer. The list indices begin with 0, not 1. It's 0 indexed. You can access the first item on a list like this. List name with 0 in the bracket. The second item is at list index 1. Computer scientists love to start counting from 0. Write a statement that prints the result of adding the second and fourth items on the list. Make sure to access them. So we will do print numbers. The second is going to be 1 plus numbers. They want the second and the fourth, so it's going to be 1 and 3. So 6 plus 8 is 14. Oh, it actually gave you the answer of what indices you needed. I didn't even look. A list index behaves like any other variable name. It can be used to access as well as assign value. So this right here is going to take the zoo animals variable here, and at index 2, so at sloth, it's going to replace it with hyena. So now they want us to go zoo animals at the index of 3 is equal to, we'll put the polar bear back. And we'll run that. And now the tiger is no more, and there's a polar bear in its place. Then you can also use functions like .append, or the append function, which will add that value in the function to the very end. So in suitcase up here, in suitcase right up here, we have an empty index, or empty list. So suitcase.append is going to put soup or sunglasses in it at the very last index available. So if there was more, if there was more in that, it would just add it right to the end. So on lines 5, 6, and 7, append 3 more items to suitcase. So we'll do suitcase.append sunglasses. We'll do swim trunks. We'll do we'll keep a beach theme. We'll do sunscreen. We'll do towel. Then set the list length equal to the length of the suitcase list. So this is then going to be the length of suitcase. So you can see we printed, or we added swim trunks, sunscreen, and towel just by adding it right to the end of the list. And so we know that that's what's in there. So if I did suitcase.append and added something else, it would go right in there after towel. Sometimes you only want to access a portion of a list. Consider the following code. Letters equals A, B, C, D, E. Slice letters 1 through 3. So it's going to take B, C, and D. Yeah, so slice equals those 3 letters. Print slice and print letters. So it's going to cut them out. So you'll just have A and E left on that. Oh, I was wrong. So that slice isn't actually going to take them out. It's just going to print those. Okay, and then that slice, it doesn't include the final index. So that 1:3 is only the first and second index in the list. So it's going to be B and C, not B, C, and D. I was incorrect because I didn't read before I spoke. So on line 7, create a list called middle, containing only the 2 middle items. Middle is going to equal suitcase. The 2 middle items, so passport and laptop. So it's going to be 0, 1, 2 through 4, which is just going to be the second and third. And this last one is going to be 4 6. 0, 1, 2, 3, 4, 5. Yeah, so that's all correct. So dog. From 3. Oh, so it's going to be 3 to 6. So it'll be like that. Then assign frog to a slice of animals from index 6 until the end of the string. So frog is going to be animals, index 6 to the end. Yeah. So sometimes you need to search for an item on a list. Animals, a list of ant, bat, and cat. So you can do print animals.index bat, and that'll print 1 because bat is at an index of 1. So use the .index item function to find the index of duck. assign that result to a variable called duck index. Duck index equal to animals dot index duck. Then insert the string cobra at that index. So then we are going to do animals.insert at duck index and we want a cobra. Okay. I don't know why they would say your code here when they clearly wanted it right here. There we go. Fixed it. Yeah, so they give you your code here, but they started it and commented it out up there. Whatever. Okay, for one and all, if you want to do something with every item in the list, use a for loop. We've learned about for loops in JavaScript. Pay close attention, they're different in Python. So the variable name follows the for keyword, so for variable in list name, then it'll take the action. It'll be assigned the value of each list item in turn, then in list name, designate list name as the list the loop will work on. The line ends with a colon, and the indented code that follows will be executed once per item in the list. So write a statement in the indented part of the for loop that prints a number equal to 2 times number for every list item. So we'll go for number in my lists, print number times 2. And that does that. So if your list is a jumbled mess, you may need to sort it. First, we create a list called animals with 3 strings. The strings are not in alphabetical order. Then we sort animals into alphabetical order. Note that .sort modifies the list rather than returning a new list. Then for each item in animals, we print that item out as ant, bat, cat on their own line each. So write a for loop that iterates over the start list and appends each number squared to square list. Then sort square list. So we're going to go for number in start list. Let's see. It iterates over start list and appends each number squared to square list. We'll do square list dot append number squared and then we sort square list. So square list dot sort, and then we'll print it out down here. Done and done. That was super simple. Dictionary is similar to a list, but you access values by looking up a key instead of an index. The key can be any string or number. Dictionaries are enclosed in curly braces, like so. So it'll be D equals, and it's a dictionary with key of key 1, and the value is 1. Key 2, the value is 2. Key 3, the value is 3. I literally just summarized that. Dictionaries are great for things like phone books, pairing a name with a phone number, login pages, pairing an email address with a username, and more. So print the values are stored under the sloth and Burmese Python keys by accessing dictionary values by key. Or accessing dictionary values by key is just like accessing list values by index. So it would be a print residence, and I would go, it wants sloth and Burmese Python. Okay, fine. Sometimes they're not clear how they actually want it done. Like, I don't know if they wanted it in 2 print statements or if they wanted it in 1. And clearly they wanted 2 print statements. Like lists, dictionaries are mutable, which means they can be changed after they are created. One advantage of this is that we can add new key value pairs to the dictionary after it's created, like so. An empty pair of curly braces is an empty dictionary, just like an empty pair of square brackets is an empty list. The length function of a dictionary is the number of, well, the length, or use the length function, is the number of key value pairs it has. Each pair counts only once, even if the value is a list. That's right, you can put lists inside dictionaries, and it gets really confusing if you aren't super familiar with the concept. So add at least 3 more key value pairs to the menu variable. With the dish name as a string and the key for the key and the price a float for integer as the value. So here's an example. So we can do menu. We'll do spaghetti, keeping with the Italian theme here. That's going to be equal to, we'll do 1350. Then we'll do menu. Chicken parmesan, but with that we'll go 15. and we'll do that. I was right, I just didn't add enough. That'll be inexpensive. Whatever. Done. Because dictionaries are mutable, they can be changed in many ways. Items can be removed from a dictionary with the delete command. Delete dictionary name, key name, will remove the key name and its associated value from the dictionary. A new value can be associated with a key by assigning a value to the key like so. Dictionary name key equals a new value. Delete sloth and Bengal tiger from the zoo animal. We'll do delete animals. They want sloth gone. And we'll delete sloth and Bengal tiger. Then we can do rockhopper penguin equals, where do we want to put it? It'll go in the rainforest for now. There we go. I did penguin instead of penguin. Penguin. Remove a few things. Sometimes you need to remove something from a list. Beatles equals John, Paul, George, Ringo, and Stewart. Beatles.remove Stewart, print Beatles. And it just rips it right out of there. So now we need to do backpack.remove, and we'll do dagger. Super simple. Dangerous to go alone. Take this. Example above, we created a dictionary that holds many types of values. The key fish has a list, the key cash has an integer, and the key luck has a string. Finally, we print the letter C. When we access a value in the dictionary, like my dictionary fish, we have direct access to the value, which happens to be a list. We can access an item at index 0 in the list, stored by the key fish. Add a key to the inventory called pocket. So add a key to the inventory. So we're going to go inventory. that is going to equal seashell strange berry and lint. Sort the item. The list stored under the backpack key. And then we're going to do dagger. And then gold plus equals 50. Done and done. All right, and like I said, I was just going to finish that little section and then I'm going to call it a night. I'm going to try to get to bed in like the next hour or so and actually get some sleep, because coming up tomorrow we're going to go back to working on Meramos and do the Godot game development. And I think my goal for the end of tomorrow's stream is to actually have just a working rudimentary combat, because last week we got the random encounters functioning so that we can walk around and get into random combat. So now we'll actually build out the combat and get a few basic enemies for the area. Maybe start a... Well, we'll use actually a little bit of the stuff that we did today here with the lists and dictionaries. We'll create a dictionary that contains the different enemy types for the areas we're in. And so when we get into combat, we'll randomly draw enemies from that dictionary and insert a random number of them into the combat. And I think that is our goal for tomorrow. So on that, I am going to get out of here. Thank you for stopping by and joining me. Come back tomorrow. We'll do some game dev. And I also do Stardew Sundays with Lorem Gypsum. So drop by for that as well. I hope to see you soon, and good night.